This video lecture covers field data in remote sensing and geographic information systems, GIS. Field data are observations collected at or near ground level that are used to support remote sensing analysis. Essentially, an analyst uses field data to match points on remotely sensed imagery to points on the ground surface, which creates a relationship between the image and conditions on the ground. As Campbell and Wynne note, there are three kinds of information that must be included in field data. First, field data should include attributes of measurements describing ground conditions at a specific place. Second, observations should be linked to location and size to aid in correctly matching attributes with points on the image. Third, observations must be described by date and time. Attributes, location, and time are the three elements considered as minimum information required for useful field data. Other components of field data may include weather conditions, name of the human project participants, equipment maintenance, and other such project information. There are many types of field data, such as nominal data, biophysical data, and radiometric data. Nominal labels offer qualitative designations and are applied to regions on imagery that convey differences with adjacent regions. The purpose of nominal field data is often to reconstruct ground or atmospheric conditions, so the imagery must align with the place and the time that the imagery was acquired. Keep in mind that careful and complete documentation is required. Field data and its application in remote sensing are only as good as the information recorded, its readability, and accuracy of collection. Documentation is critical. Land use land cover classes are examples of nominal labels, such as urban and built up, agriculture, water, etc. Biophysical field data capture measurements of physical, chemical, or biological characteristics collected in the field. Examples include the type, size, form, and/or spacing of plants, soil texture or mineralogy, the leaf area index, LAI, biomass, soil moisture, total phosphorus, and other similar measures. These biophysical field data do not replace nominal data, but rather add meaning to the nominal labels. Another example of field data is radiometric data, which relates brightness recorded by the aerial sensor to the corresponding brightness near the ground surface. As part of the minimum required information in field data, locational data matches field requirements with the same region in remotely sensed imagery. Global Positioning System, GPS, provides convenient, inexpensive, and accurate measurement of absolute location, and it has greatly enhanced the usefulness of remotely sensed data. A GPS receiver can be a portable receiving unit that is sensitive to signals transmitted by a network of satellites orbiting the Earth, and consists of antenna, power supply, electronic clock, and circuity. The GPS receiver translates signal into positional information. Excuse me. A satellite-based navigation system, GPS is a network of 24 satellites in precise orbit, achieved in 1994, that was initially established by the Department of Defense, DoD, but was made available for civilian use. The first GPS satellite was launched back in 1978. The satellites orbit Earth at about 12,000 miles elevation. In constant motion, each satellite completes 2 orbits in less than a day, traveling at some 7,000 miles per hour. These satellites are powered by solar energy with backup batteries, and small rocket boosters keep them on the correct path. The average expected lifespan of a GPS satellite is 10 years, and replacements are in constant production and launching. A single satellite weighs some 2,000 pounds, and when the solar panels are extended, can span 17 feet across. We call this network of satellites NavStar for Navigation, Signal, Timing, and Ranging Global Positioning System. As Howell notes, excuse me, quote, the orbits of GPS satellites are inclined to the Earth's equator by about 55 degrees. The system is designed to ensure that at least 4 satellites are visible at least 15 degrees above the horizon at any given time anywhere in the world. End quote. To estimate location, GPS signals can be used through pseudoranging or carrier phase measurement. Pseudoranging is based on time differences as a means to estimate distances. In contrast, carrier phase measurement is based on detailed examination of signals broadcast by satellites with respect to the Doppler principle. By design, the GPS system satellite signals had been encrypted for military use, but the US government turned off encryption in the year 2000. Some sources of GPS error include orbital position, clock error, ionospheric effects, tropospheric effects, noise contributes by the GPS receiver itself, and multipath error. Local differential GPS is the process whereby a GPS receiver stationed at a fixed point of known location is used to derive errors that influence GPS accuracy. These errors are then applied to estimates of location to improve accuracy of GPS positions at unknown locations. The Wide Area Augmentation System, WAAS, developed for civilian aviation, is an established means of local differential GPS, which uses wide area reference stations, WRS, that have a known location. Known errors are forwarded to WRSs, which then relay the error estimates back out to receivers. WAAS-enabled receivers may have realized accuracies of some 3 feet or less. There are many different geographic sampling patterns available to gather field data in the field of remote sensing and beyond. For example, some of the most common sampling patterns include simple random sampling, stratified random sampling, systematic sampling, systematic stratified unaligned sampling, and cluster sampling. Each sampling design has specific utility to the field research, and great pre-planning effort should go into selecting the most appropriate sampling design for any project prior to field deployment. One final consideration regarding field data is the concept of spatial autocorrelation, which describes the tendency of measures at one location to resemble those at nearby locations. Spatial autocorrelation is an important consideration for selecting sampling patterns and pre-processing imagery. The following references were consulted in developing this video lecture.